This is a demo video for the final year project, Semantic Aware Visual Localization with Attention. Visual place recognition is very challenging in urban environment because the scene may have both dynamic objects like cars, people, and sky, and static objects like buildings, roads, and terrains. Take these two pictures as an example. Although the pictures are taken at the same place, you can see that the images are different in the bottom part. These features could severely devastate the performance. In order to let the model focus on the static object, an attentional mechanism is generally being used by assigning each feature a relevance weight. However, such approaches cannot precisely label every feature correctly. The APP-SPR utilizes distance between feature descriptor to separate dynamic features from static ones. However, as shown in the slides, it still has some features that are mislabeled. In contrast, the SOTA semantic segmentation model is able to provide a quite accurate semantic segmentation result. Thus, a hypothesis is proposed that if a deterministic binary segmentation filter can be added to the original attention mechanism, the result of visual place recognition may be improved. The filter, which is trained as semantic segmentation model, may better distinguish that static from dynamic objects. So this is the method. The first utilize the SOTA semantic segmentation model mask transformer to label all trained set images. Second, train a UNet segmentation model on the labeled dataset created in the last step to separate static and dynamic objects. Third, generate feature map using VGG16 and obtain feature interweights from semantic initialized NetVLAD layer. Fourth, apply the binary filter to the weighted feature map from the last step as shown in this picture. Fifth, and the last step, aggregate the feature and obtain the final image descriptor as VLAD. The results from 4 different models, NetVLAD, StereoNet, UNet filter, and mask transformer filter, are used to compare. StereoNet, UNet filter, and mask transformer filter are sharing with the same semantic initialization data. From the figure, we can observe that the mask transformer can perfectly distinguish static objects from dynamic ones. UNet can also perform quite well on the segmentation of the image. From the numeric data, mask transformer filter achieves the highest recall rate among all. UNet filter can also achieve a relatively good recall rate as the mask transformer filter. So in conclusion, the result has shown clearly that the deterministic binary filter is able to improve the performance of the visual place recognition model. However, currently, the UNet model based on VGG16 features cannot segment the image perfectly. In the future, a deeper backbone like ResNet 15 should be used to generate the feature map. Besides, the current filter is binary-based, assigning the same weight to all static features. However, it is obvious that the different static objects may have different importance to the VPR task. Thus, the filter may be improved by assigning different weights to different categories of objects.